All right, I think we'll just get started. My name is Michael Friis. I'm a product manager at Docker. And actually, I'm a little bit out of my element talking about plumbing and whatnot, both because I'm a product manager, but also because I mostly work on the Windows and Microsoft-related stuff that Docker does with Microsoft. So the stuff that Michael and Caesar and those guys are working at a print also. I do also work on what we call the Docker editions, though. So Docker for Azure and Docker for AWS. And I also spend a ton of time working on Docker for Mac and Windows. So I do know a little bit about this stuff, but bear with me. This is not my day job. Before Docker, I worked at Heroku for 3 years. So doing kind of pre-Docker container as a service. Before Heroku, I co-founded a startup called AppHarbor, which still exists. It was basically Heroku for .NET. So we built a platform as a service on AWS that built and ran ASP.NET apps. All right, so let's get started. What I'll try to do is just kind of give a brief history of how people have provisioned container systems for the cloud, looking at it from kind of Docker's context. So the first thing that Docker came up with was a piece of software called Docker Machine. So if you started using Docker a couple of years ago, you were probably using a Docker Machine, and there's kind of two useful things that Docker Machine can do. It can both provision kind of local development VMs using like VirtualBox or Hyper-V or VMware also. But lots of people also use it for provisioning cloud VMs. So basically, you can feed Docker Machine your AWS or Azure or DigitalOcean credentials, and then it'll go and provision a VM on that infrastructure and try to set it up with Docker Engine and make it usable. So it's pretty useful for kind of setting up a single development VM. It also got sort of limited swarm support later on, so that you could set up kind of Docker Swarm 1 systems. But it was mostly focused on kind of single VM scenarios. It proved wildly successful, though, it was because it was a great integration point for infrastructure providers. Like they could go write a Docker Machine plugin, and then that was kind of a way for them to advertise Docker support. There was a driver that created a kind of Docker host on their infrastructure. It did have some limitations, though. Or I should say, it's still actively maintained. It was kind of very fire and forget. There was no notion of keeping a host updated with operating system updates or updating the Docker engine. And doing more complex setup and self-healing and all this stuff was not really in scope. So especially for onboarding new users, Docker Machine had a bunch of reliability problems. So we actually, to solve just the development use case, not the cloud provisioning use case, we built something called Docker for Mac and Windows, which are kind of more coherent, and I won't go into details about this, but they're kind of more coherent development setups that you install on your Mac or your Windows machine. And they also ship with Docker Machine, but Docker Machine is actually not what's used to provision the Docker environment. Instead, that's much more integrated setup, which is more dependable. So what then happened with Docker for AWS and Azure was that we wanted to try to do something similar that we did with Docker for Mac and Windows with AWS and Azure. That is, instead of having this kind of semi-generic framework in Docker Machine for provisioning cloud hosts anywhere, we wanted to see what kind of Docker experience and what kind of container experience can we build if we just focus on making something that's really focused and really great for AWS and Azure. And we wanted to make setup in Bootstrap super simple and just ship a minimal custom Linux that we set up. But then we also wanted to take make maximal use of what was good about that infrastructure. So like ELB, load balancers on AWS, whatever scaling features are available on AWS and Azure, and so on. And also try to build self-healing into the systems. So yeah, I'll just give you a brief demo of Docker for AWS. Oops. So basically, what happens, the way people install Docker for AWS is that it's a CloudFormation template. So you click a launch stack template, and it's exactly the same for Azure. And that you then go through this kind of pre-populated AWS wizard where you choose the amount of managers and worker nodes that you want, and the instance sizes, all this other stuff. And you choose an SSH key that you want to use. This is a shared account, so there's a bunch of keys. Then you click next, and you accept that that's all good. And then when you hit create, AWS basically goes and spins up a set of VMs and creates a VPC, networks, subnets, and load balancers required to run Docker on AWS. So it takes a couple of minutes, so I already pre-created one here. What you get when it's created is SSH target, and then a default DNS target where your web apps will be hosted. So just to give you an idea of what that looks like. Oops. Just gonna SSH in. Oops. Then I get a prompt. So I'm now on one of, basically in a container that hosts a SSH session or a shell session on one of the managers. And I have all my kind of usual Docker commands here. I can do Docker, and this sets up like a full swarm, so I can do Docker node ls, and you can see this five nodes in this swarm, 3 managers and 2 workers. And I can check to see if there's any services running. It's not, so I can go create one. Docker service create. Like so. And now the Nginx service is booting. So the goal with Docker for AWS and Azure was to make setup and Bootstrap super simple. We can also go take a look at more of the kind of resources that were created as part of the setup. So if we go look through this stuff, there's this VPC, which kind of contains a virtual private cloud that contains all the resources, and then there's a couple of scaling groups, one each for the manager and the worker nodes. And we also create ELBs, both to target the managers and also one to be used for general purpose app hosting. So the neat thing about that is that whenever you create services that expose ports like this Nginx one does, we actually go and plumb or expose that service through the ELB load balancer, so that I can now access the Nginx website on the ELB that was part of the Docker for AWS setup. So that's kind of an example of the tight integration that we wanted to try and build with Docker for AWS and Azure, and it works the same on Azure. Some of the other things that we do is we set up CloudWatch logs so that logs go somewhere reasonable so you can figure out how to debug stuff that's happening with your app. And we're wanting to also configure volume plugins and stuff like that. All right. So one of the things that proved really hard was managing upgrades. Like if you want to try to build a serious setup on AWS, it's really critical that it's easy for users to apply security upgrades both to the Docker engine. So kind of Docker gets them the ability to update their apps, but they also need a way to update the Docker engine or the underlying Linux if there's a security problem or a new feature update. And you can actually do that with the way Docker for AWS and Azure works right now. So the way it works is that we use the built-in AWS features. So there's an action to update the stack. And what you can do is tell Amazon that there's a new template for this stack, and then Amazon will go figure out what are the changes between these two templates, and how do I make those changes to update the stack. So the way we ship updates for AWS and Azure is basically it's a new machine image, a new AMI or VHD on Azure with an updated Linux and updated Docker engine, and then a new CloudFormation template with that both references those new AMIs and whatever other updates there are. So here you can see a list of the proposed changes. So if I hit update, AWS will now start applying this update. So right now I'm updating from beta 9 to beta 10 of Docker for AWS. So one thing, this works on AWS, but it's very complicated to do right. And one of the reasons for that is, for example, the way Docker Swarm works, and I think it's similar in Kubernetes for the etcd setup, you have to be super careful about maintaining the manager quorum. So when you do an update, we have to switch out the nodes one at a time. Like switch one out of the manager quorum, switch a new one in, all the while making sure that there's a leader and that the quorum is maintained. And just because CloudFormation is fairly primitive, that's really hard to do. So actually, the way this works is that we run a set of manager containers on top of the swarm, and we subscribe to SQS events from AWS so that we get a notification whenever AWS has decided, for whatever reason, that this node needs to be retired and a new one is being brought up, so that we can block on that takedown action, and then go clean up and leave the manager quorum, and then tell the AWS CloudFormation machinery, hey, I'm done cleaning up now. You can remove me, and then AWS goes and removes it, and a new manager can be brought up. So this works, but it's really finicky, and it's very specific to AWS. So one of the things we could kind of see is we could barely make it work on AWS, and it was going to be, we also had to make it work on Azure, and if we wanted to bring this kind of experience to other clouds that were less mature and had less kind of sophisticated stack templating machinery, it was just going to be impossible. Yeah, so this slide just kind of goes through some of the stuff I already mentioned, like what goes into Docker for AWS and Azure. There's the Linux and Docker AMIs and VHDs on Azure. Then we run a bunch of service containers that manage the stuff I just described, the updates and so on. We set up logging. We run there's a kind of debug utility that lets you easily do dumps that you can send to us, so we can help you debug if something went wrong with your swarm. And then we configure load balancing and we do the upgrade management. So some of the takeaways with building these were how to maintain a consistent experience. So because we ended up having to leverage AWS and Azure so heavily, the experience of using Docker in those two places is not always the same. And yeah, then as mentioned, it's going to be really hard to do something similar on less mature infrastructure like DigitalOcean or on-prem if we want it, where it's not evident how we would build good upgrade functionality or build in self-healing if we can't rely on stuff like scaling groups and scale sets on AWS and Azure. So that kind of got us started on InfraKate, which is an open source project that Docker announced a couple of months ago. So it's a toolkit for building a declarative self-healing infrastructure. And I want to emphasize it's not just for maintaining kind of Docker infrastructure. The example that Bill and David, who are working on this, gives most frequently is maintaining a SoupKeeper cluster, for example. And it works just fine for that too. But the impetus for getting started with InfraKate was as a component that we can use to build stuff like Docker for AWS and Azure and the other kind of Docker Bootstrap installers that we want. So I think this slide actually kind of resembles what was shown in one of the first keynotes yesterday, showing kind of the different components that go into running something like Docker or Kubernetes on a piece of infrastructure. So you're going to be running Linux or in the future Windows at the bottom. Then you run whatever container engine you're interested in, and then a bunch of plugins, and then only at the very top are user applications. So the thing we wanted to try to, the hole that InfraKate fills is that kind of infrastructure management piece. Yeah, so I'm gonna demo InfraKate in a little bit, just to go through some of the features. So it's declarative, which means that the desired state of a piece of infrastructure that's managed by InfraKate is declared in a JSON configuration file. So that contains kind of what instances you want running, what groups are required, and so on. And that serves as a config that you use to both bootstrap and start some piece of infrastructure that you want to manage, but changes to those JSON files also drive updates, as I'll show in a little bit. So it's declarative, and then it's self-healing, which means that InfraKate runs as a service continuously monitoring the state of the infrastructure under management. So that's both to detect updates to the configuration, but also detecting if anything's gone down, what needs to be brought back up to maintain the desired state. Yeah. So let me just there's a diagram here showing how it all fits together. So basically, the InfraKate's daemons are what's on the left. So there's always a leader, and then there's standby daemons available if you want that have full knowledge of the desired state of the infrastructure under management. And if the leader InfraKate controller goes down, the standby ones can take over management. because we wanted InfraKate to be a kind of a generalized toolkit, there's a plugin infrastructure. So again, the demo that Bill and David uses creates vagrant VMs. We also have a Bootstrapper for AWS now that creates EC2 instances. And I'll show an even simpler one that actually just creates files. But all of that is pluggable so that we can reuse InfraKate and the community can reuse InfraKate to manage whatever infrastructure is desired. Yeah, so instance plugins and then flavor plugins. Flavor plugins basically describe properties of the instances of particular instances that you want. Yeah, so like zookeeper members, managers, Docker Swarm nodes, etc. And then finally, there are group plugins, and groups are the kind of typical things that you go and create. Yeah, so let's get on with the demo. All right. Okay, so let me bump up the font. Like so. Okay. So here I'm in a Linux VM, and I basically just checked out the InfraKate source code. Oh, could you see the other demo? Oh, what? Okay, that's good. Oh, why is that happening? Okay, thanks. Okay, so I'm on a Linux VM, and I just checked out the InfraKate source code that I built. Yeah. So the result of that is that I have the InfraKate executables in the build directory. All right. So let's see. Yeah. So the first thing I'm going to do is start the group manager. So that's up and listening. Let's see. Then I'm going to, so what I just did now was I started the file instance plugin. So the file instance plugin is this really simplistic plugin that's just used for testing. And basically, instead of, typically instance plugin would create some sort of instance, like perhaps a VM with VirtualBox or EC2 instances or Azure instances or something similar. But this one just goes and creates files. So it's good for kind of demoing and testing. And then I also need this one. Now I can do plugins ls to see the plugins that are running right now. So that's the group one, and I have the instance file plugin, which is what I need. The reason I just kind of need a vanilla flavor that does nothing, but is applied to the instances. So yeah, just you can ignore that. All right, so with the describe command, I can describe the sets, the instances that are currently managed by this instance plugin. So there's none running right now. So now I'll go. So I already have the kind of declarative JSON files in this directory. So we can do cattle.json. So what this says is I want 5 files, and it's going to use the file plugin. And then this is kind of just filler to apply some tags, and some filler for the flavor plugin. So we don't have to worry about that. Then I tell InfraKate, the group plugin, to start watching cattle.json. And you can see InfraKate went ahead and created 5 instances because that's what I specified in the declarative JSON file. So we can go list those if we want. And they're there. And to look at the kind of physical manifestation of this, I can list what's in the tutorial directory, which is basically where the files that are created by InfraKate are. So that's all well and good. Then to demo kind of updates, I have a kind of what would be an update to this configuration. So this is cattle2.json. It specifies that I want 10 instances, and then it has a different kind of note to it. So I can just do I can just diff those two to show you. Yeah, it just changes the size and the note. So a neat thing is that I can ask InfraKate to describe, before applying the update, I can ask InfraKate to describe what would happen if I applied this update. So it tells me that it would perform a rolling update of 5 instances, and the reason it needs to do a rolling update of the 5 instances is because of the changed note. So in a real-world example, this would be because I changed maybe the Docker engine version or some other kind of property of the instance. And then it says it also needs to add an additional 5 instances to bring the total up to 10. So I can then apply the update, like so. And it's now applying this update, hopefully. Yep. So what we're doing with this right now is that we're beginning to write plugins for AWS and Azure and for other kind of infrastructure providers that we know we want to support. And then we can kind of start incorporating InfraKate into Docker for AWS and Azure and the other places where we want to have really great Docker experiences. And so again, I want to emphasize that InfraKate is not specific to Docker. You can use it to manage a soup keyword cluster or Kubernetes or anything else. Let's see if I can get this on the way. Okay, so the update is now applied. So I can look at, whoops, that's not good. Oh, here we go. So there's now 10 files in the tutorial directory. And if I were to go to, just to kind of show the self-healing aspect of this, if I were to go delete one of these files, InfraKate is monitoring it, and it noticed that there was no longer 10 files in the directory, so it went and created a new one. So we just do ls again. And now there's a different instance here that replaced the one I deleted. So that will kind of represent, say this were EC2 instances running on EC2. AWS might shut down an instance, and then InfraKate would monitor the situation and automatically bring up a new one. Yeah. Yeah, so to kind of sum up our experience of this, we had Docker Machine, which is great for single instance provisioning. Tons of people still use it. But we then went and tried to create something more integrated for setting up bigger things, like bigger clusters of Docker for AWS and Azure. We learned a bunch of stuff, and now we're working on InfraKate to be a kind of more generic tool for managing clusters of stuff And the main thing we're going to be using it for is to manage Docker swarms, but it could be used to manage anything. Yep. So if you're interested, go check it out, or write me an email. That's pretty much all I had. But I'm very happy to take questions, and hopefully I can answer them, or I can forward them to the team working on InfraKate. The InfraKate repo is public. If you want to try out Docker for AWS or Azure, they're still in private beta, but if you send me an email, I can get you in. Yeah, that's all I had. Any questions? All right, cool. Thanks.